0 degrees to 360 degrees. If you see 0 to 2 pi, you know it's radians. Anything you want me to go over here? Anyone? No? Okay. So those were solving. What were you solving for here? What was the unknown? You have a question, Adam?
Yeah.
Okay, which one?
H.
On this part?
No,
Here?
the first one.
This one?
Yeah.
Okay, let's take a look at this one quick. Adam wanted to look at this one. So what am I solving for here? What are you supposed to be finding? Theta, right? So you're solving, if you're solving for something, you're solving an equation, and sure enough, they give you two sides with an equal side. So I'm solving for theta, so I shift cos, and I'm always solving for a reference angle first. If I'm lucky, my reference angle might end up being one of my answers, right? But more often than not, it's not one of my answers. I'm just going to use my reference angle to find the related angles, right? So here, I solve for my reference angle, and it is, I have to make sure I'm in radian mode, and I go shift, oh sorry, it was degrees, thank you. And I go shift cos, point, I don't use the negative. What do I use the negative for?
To determine what quadrant it's in.
To determine the quadrant. So cos is negative, whoops, in 2 or 3, right? Okay, so those are where my two related angles are going to be found. 0.2588, and I get my reference angle is 75 degrees. I think I can do this without a calculator even, because it's a nice even number. So 180 take away 75, I'm going to get what? 105? 105 degrees. And then 180 plus 75, 255. Okay. So those would be my answers. Okay? Notice you never type the negative sign in for a reference angle. You use that negative sign to determine the quadrants. Okay? So once again, you're given an equation. Whenever you're given an equation, a left-hand side, a right-hand side with an unknown, you're solving an equation. In this case, because it involves trig functions, it's called a trig equation. Trig is a little different because we have those repetitive values, and there's usually 2 answers per question, right? If they don't tell me what quadrant the angle ends in. If they told me, hey, this angle ends in quadrant 3, then I knew that this would be my only answer. But they were vague, so my answers are 2 answers per question. So I'm just on page 13. Just to reiterate, let's just see, it said example 3. Sorry, I kind of scribbled it out because I want to renumber it next time. It said determine the value of the trig function shown below to 3 decimal places. Is this an equation? Are these equations?
Yeah.
They are? To qualify for an equation, you have to have a left-hand side, a right-hand side, and an equal sign. Are these equations? These are just expressions, right? So all you're doing is find the value of each expression. So you're just typing it into the calculator, right? You're not solving for anything. There's nothing to solve for. So you're just now, what your eyes have to recognize is, should I be in degree or radian mode? What about this one? Radian, radian, right? Degree, degree. Now, because we're not solving for anything, we should just be able to type this all into our calculator, right? So cos, I have to turn back into radian mode. Okay, so cos, my angle measure is 3 pi divide 15. That should be in quadrant 1, right? Cos should be positive, and there we go. I have a cos value of 0.809 equals 0.809. Every trig function has an angle and a value, right? This is the angle, this is the value, and this is the trig function, right? There are 6 trig functions, the 3 big guys, right? 3 primaries and 3 reciprocals. Okay, this one, cosecant of this, now I could type it in as a reference angle and then find the related angle, but they actually just want me to find cosecant of negative 2 pi divide 7. So how could you punch that into your calculator just to get a value?
Sine of -7 over 2 pi.
Take the negative part.
Yeah, you could do that. I'm wondering if, you know what, I think this might, just a minute.
If you put the negative in, it gives you the exact angle it's in, right? In the quadrant and everything. Look at that one.
Okay, so you just flipped it, right, Eduardo?
The reciprocal.
One.
I don't know why that's not working. Equals sine of negative 7 over 2 pi, that's what you did? Why didn't it work the other way though?
Wait a minute, maybe it doesn't make sense if you look at the whole circle in decimals, right? If you look at the decimal value of everything. If it's 1, wouldn't it be in quadrant 2? Or, no, wait. No, quadrant 1.
This should equal, for some reason, it should equal the same thing. So let's try this. I would have done, no, let's see, okay. No, sorry guys. I'm gonna erase this. That's not what that means, sorry. I got sucked in there. Okay. So what we're gonna do is we're gonna find okay, so cosecant of negative 2 pi on 7 is going to equal 1 over sine of negative 2 pi on 7. Okay, would you agree with that? If you were given the ratio, Eduardo, you could have flipped the ratio, but we weren't given the ratio. We weren't given the value. Does that make sense? Okay, if you were given cos of an angle equals 3/5, or I'll say 5/3, then sine of the angle equals 3/5. But you can't just flip the angle. You were flipping the angle. Like you were saying like cos of, let's try this. Sorry. Cosecant of 2 pi on 5 doesn't equal sine of 5 on 2 pi. Cosecant of an angle, if that equals 2/5, like a value, that will equal sine of 5 over 2. Right? You flip the value, not the angle measure. See what you were doing? You were flipping. We're interested in this 2 pi on 5 or the 2/7 pi. That's what we're interested in. We want sine of 2/7 pi. We don't want sine of the reciprocal angle. We want the angle measure. So whatever value this is, it's going to be equal to sine of, 1 over sine of that. Okay, so I'm in radian mode. 1 divided by sine, negative 2 pi, 7. And I get negative 1.279. Yeah, you have to use the angle you're given. I'm going to try to explain it another way. This time I am, because I'm not finding a reference angle, I'm just finding the value at that one spot. You could find the reference angle and then figure out where sine is negative and you come up with, and then you could use your reference angle to come up with this. But here you can just find the value right away. Okay, once again, I think it looks weird because of the 2 pi on 7, but let's just say I wanted you to find sine of, let's do pi on 2, okay? Where's sine of pi on 2? That's right here, right? Agreed? Okay, so if I wanted you to find sine of pi on 2, and sine of pi on 2 is 1, actually, okay? So the reciprocal function is cosecant, right? Cosecant of pi on 2 is going to be 1 over 1. It'll also be 1. But the reciprocal of sine is cosecant of pi on 2. It's not cosecant of 2 over pi, right? Do you know what I'm saying here?
Yeah.
Like it's not the reciprocal of the angle, it's the reciprocal of the value. So you reciprocate the value, not the angle. Okay? What about tan of 220? Now we're into degrees, so you got to flip to degrees. I think you guys have a much easier calculator probably than I do. Let's think about this for a sec. What quadrant is tan of 220 in?
3.
Quadrant 3. Should tan be positive or negative?
Positive.
There it is, 0.839. And how about this one? Secant of minus 15 degrees. Okay, so again, we're not reciprocating the 15. This is going to be equal to the value of 1 over cos of negative 15. Now again, you could find the reference angle and then use the reference angle to find the actual value, but because you're just finding the value of one spot. By the way, what should cos, let's think about this. What quadrant is negative 15 degrees in?
4.
So is cos positive or negative in quadrant 4? It's positive, so we should get a positive answer, right? 1 divided by cos negative 15. There we go. 1.035. Okay. So again, you've got the angle measure and the value. The value is what's reciprocated when you're finding one of those reciprocal functions. Okay. Notice the difference. If I just slide over here, we didn't do this one, but I think you did enough in this last half hour. Do you notice the difference between these two, tan of 220 and tan of theta equals 4.18? This is the angle. This is the trig function, right? The trig function. This is the angle, and this is the value. Is this an expression or an equation? Equation. So you are solving for this, right? Here you're just typing into your calculator. Here you're solving. Solve for theta. You can only solve an equation. Sure enough, they give you a left and a right. This is a very simple trig equation, right? You're just going to go theta r equals shift tan 4.18, right? And this will be, I guess we could do this one just quickly to finish it all off. Am I in degrees or radians? This one said degrees, okay? So I'm going to make sure I'm still in degrees. That's nice. Shift tan 4.18, and I get, let's just round to, yeah, it said round to the nearest degree. So it'll be what, 77 degrees? Okay. Now, it said solve for, determine all values in both positive and negative rotation. So tan is a positive value, so it could be quadrant 1 or 3, agreed? So my quadrant 1 answer is always going to be my reference angle. What will quadrant 3 be? What'd you say, Joanna? 257? Okay? Let's go in the negative rotation now. That was positive. And positive means the numbers you need to keep in your head are the 0, the 180, and then the 360. And in the negative, you have to keep those same numbers, but in a negative, right? So it'll be at 0, negative 180, negative 360. Tan is still positive here and here. Okay, I'm going to give you a sec to come up with the answers in a negative rotation in these two quadrants. And they should make sense, right? If you label your x-axis, you'll know if your answer is right or not, because you got to kind of know what the numbers should be. Okay, Dee, did you have an answer for here? So 77 is your reference angle. So what will the answer be in this quadrant? So you're starting at negative 180 and you're getting smaller in the negative, so you should be adding your reference angle. Did you do it? This part? Okay. The only reason I'm doing negative rotation is that's what it said here, right? I have to go positive, negative. Okay. So would you agree that tan is positive in these two quadrants? That never changes, right? So if I want to find, here's where my reference angle is, right? Here's my positive x-axis, right? So I'm moving this way. What direction is that? That's actually, even though they told me to do a positive rotation, if I'm moving away from the x-axis this way, I'm going to be adding my reference angle. So that should be negative 180, add 77, and that gives me negative 103.
See what I was doing is I was taking your initial knowledge and subtracting it.
Okay. Do you want to explain that way to John? Do you want to go up to the board and explain that way, Eduardo? Because I think that might be easier. So here, what I would do is I would say, okay, this is my negative 360, because that's my closest x-axis, agreed? That's my closest x-axis in quadrant 1. Okay, so again, my reference angle is more in quadrant 1. This is my starting position, and I'm moving this way. I'm starting at negative 360, right? And to move to my terminal arm, I'm going to have to move in the positive direction, and that gives me negative 283. Okay, Eduardo, you want to go forward and explain your way, if you don't mind? Because I think it's great to have other ways to explain it, right?
It's just
See if this makes sense, Dee.
you take whatever positive values you found. In this case, it was 77 and 257, right? So 77 and 257, and just take 360 away from both of those, and that's your next one. So
Take 360 away because you're going in a negative rotation,
yeah,
right?
in a negative rotation, it'll leave you at the same value, but in a negative
Can I be
position.
your assistant? See what Eduardo's saying? So, when you're doing negative rotations, so, let's just say here's my first angle, right?
Yeah.
My reference angle happened to be my answer because it was quadrant 1, right?
Right.
Quadrant 3.
If you start here, instead of starting here, now you're starting here and going 360 negative and you'll end up at the same starting arm, you know what I mean? If you start here and do 360, you'll have 360 here, but I'm just changing the starting point.
Because the angle measures don't change, right? These are my answers. Here's my first answer, And then here's my second answer, right? Here's my first theta in quadrant 1, I guess, and my second answer, quadrant 3 theta, right? Agreed? So Eduardo's saying, just because these don't change, you're just coming at them from a different direction. So he's coming at them from, he's coming at them from a negative direction now. He's still looking for this part, right? No, I shouldn't have done that.
Instead of measuring from the x-axis, I just measure from whatever angle we have.
So he starts here at 77, and what's he gonna do?
Just go back.
He's gonna go in a negative rotation till he hits that again.
Yeah,
So that was minus 360.
that's all it is.
And then he starts here, same thing, he's going in a negative direction, right? And it was what, what was it, 280,
257.
257? Minus 360.
And that's it. And whatever that is, it's going to be your answer.
I'm always using the true, like how I defined what related angles were, like using the x-axis, but that's probably a quicker way. We'll talk about that again, because I can see that that's still I'm going to figure out, maybe we'll do a little exercise tomorrow and try and address that a little more.
Because if you measure...
It makes perfect sense to me what you did, but I can see that. Think about that when you go home, John, okay? It's not just you, it's probably other people too. We'll come back to that. Maybe there's another strategy too that someone else is using but that's a good way to do it, Eduardo. That's a very slick way. Easier than mine. Okay, are we ready? Let's just begin this because this is a big deal. We're finally going to talk about the special angles. Now, I think you might have some exposure to this from the grade 11, I'm not sure. And if some of you have, maybe it's been a while. But now we're moving to the part of grade 12 trig where we're going to be leaving our calculators behind and we're going to be solving trig equations with no calculator, just from your memory. And the reason we're able to do it from your memory is because the relationships in trigs, they have a really unique relationship, and it starts to make sense the more that you study them. So what we're going to do is, they're called special angles, okay? And you'll see why they're special angles. And it says, determining the exact value of a trig ratio means you determine the ratio without a calculator. So now we're talking about the ratio itself, right? The value can either be, remember that the value can either be given to us, once again, sorry, as a ratio, or sometimes they actually type that ratio into the calculator. They do the 2 divided by 5 and they just call it 0.6 or 0.85, right? So the ratio itself, the value of the ratio can just be given in fraction form or in decimal form. We're going to use for special angles, they're always given to you in ratio form as a fraction. So we can determine the values of the 6 trig ratios by using our knowledge of right angle trig, the Pythagorean theorem, isosceles triangles, and 3069 triangles. So these are what you're supposed to know in grade 12 trig. You're supposed to be able to know from memory sine, cos, and tan. And we're just going to concentrate on the 3 primaries because the 3 reciprocals, you can just flip the ratio values. So we're going to talk about the 3 primaries for reference angles of 45 degrees, okay? The first thing I want to do is, let's just identify the related angles to 45 degrees or pi on 4. Everyone agree that 45 degrees is pi on 4? Okay, and how did I get that? I just multiplied by pi on 180, right? And you'll see that 45 and 180 have, well, 45 goes into 180 4 times, right? So that becomes pi on 4. 90 goes into 180 twice, so 45 goes in. So 45 and pi on 4 are, they're equivalent angle measures, just in different units. Okay, so if this angle measure is 45 degrees, by angle measure I mean like this from here to here, right? And 45 degrees is, your axes are, the Cartesian plane, the axes are set at 90 degrees to each other. So half of 90 degrees is 45. So if this angle is 45 degrees, my related angle would be 45 degrees away, right? That's my reference angle. So what would this angle measure be then from here to here? 45 away from 185? Yeah. It'd be 135 degrees, right? And it would also be 3 pi on 4, you're right. 3 pi on 4. And that's how we say it. We say it 3 pi on 4. Okay, let's do the radians first. So this is pi on 4. It's already listed here. So this is 1/4. 1/4 away from a full pi, because remember this is a full pi, right? Agreed? 1 full pi. If I'm talking in terms of quarters, I could think of this as 4/4, right? 4/4 pi, because that can kind of help. Okay, now I'm 1/4 away. I'm 1/4 over the x-axis this way. So what would this be in radian measure? 5/4, right? We always answer in improper fraction, never mixed. Agreed? So if this is 1/4 away here, what would 2 pi be? By the way, 2 pi, this is 0. 2 pi would also be equal to 8 pi on 4, right? Maybe I'll do this. 4/4 pi is another way to say just 1 pi. Okay, so I'm 1/4 short of 8/4. What would that be? 7/4. Okay? So let's do degrees. Degrees are easier. This is 45 degrees, 135 degrees. Okay, what would this guy be? It'd be 225. 225. And what about this last guy? He's 45 degrees away from a full circle. 315. Okay? So you should know both of those measures. Now notice in the pi on 4 family, there's 1 pi on 4 angle or 145 degree angle in each quadrant. And that's how it'll be. Okay, that's your family. There's 4 angles to a family, right? So you have 4 angles that are associated with the angle measure 45 or 4 angles that are associated with pi on 4. We're doing both units at once. Okay, so now what we have to come up with is, we have to come up with the sine, cos, and tan. I guess I should have put these in here maybe, right? My pi on 4 or 45. Okay, so I have to come up with sine, cos, and tan for my pi on 4 angles. Now the nice thing is, remember that sine, cos, and tan have the same values, like the same ratios, the same fractions associated in each 4 quadrants. The only thing that changes is their positive, negative signs, right? According to the cast rule. So depending what quadrant they are, the cos is positive here and here and negative here and here, but the actual values stay the same. So if I can just come up with the values for quadrant 1, I can just transfer all those values to the other 3 quadrants. They'll be the same value. So how do I do that without a calculator? Well, we're talking about the unit circle, because it doesn't matter how big the circle is, right? How big the radius is. The angle measures stay the same, right? 45 degrees, this is 45 degrees no matter if the radius is 1 or 6 or 10. So we're going to keep that the radius is 1, because that will help us out with our trig ratios. If we know that the radius is 1 and we know this is a 45 degree angle and this is 90 degrees, what do you know about this angle measure, by the way? It also has to be 45, right? Because remember your 180 rule? 3 angles in a triangle must equal 180. So if this is 45, this has to equal 45. Okay, what do you know about a triangle with 2 angles, 2 base angles that have the same size? What do you know about the size of the triangle? They also have to be equal, right? It's called an isosceles triangle. So these guys have to be equal. Even though you might think of this as the x length, and this is the y length, or this is adjacent, this is opposite, you can think of it in those terms, but you know that they're equal in this case. So if I just call this for sake of argument x, this length also has to be x in length, right? And using Pythagoras, because this is a right angle triangle, I'm just going to move down here to the bottom of my page. I know that x squared plus x squared equals the hypotenuse squared. Agreed? Okay. So, x squareds they're like terms. 1x squared plus 1x squared equals 2x squared. 2x squared will equal 1, right? Okay. Could you solve for x squared? How would I solve for x squared? So x squared equals 1/2, right? That means x will be equal to the square root of 1 over 2. And I'm leaving it in the positive because this is actually the side of a triangle, right? So it has to be, it's a distance, so it's a positive in length. Okay, and then we can say that, I can simplify this a bit more, right? The square root of 1 is 1, and I would just have to write this as root 2. Now, this is acceptable. I could just say that x equals 1 over root 2. So that's going to be the side of this triangle. However, I can see that in your book, in your textbook, they actually rationalize things. So they call this, you know what they would do? They multiplied by root 2 on 2, and they said that x equals root 2 over 2. Everyone fine with that? You can. And actually in the Pearson textbook that we use, Pearson leaves it not rationalized. You'll see half the textbooks and half the websites in math just leave it like 1 over root 2. And the other half do root 2 on 2. But at this stage in your math degree, you should recognize those are both the same, right? Okay, so if we know that, why does that make a big deal? Well, you know what? Actually, you know what? I am going to leave this blank. I'm just going to leave mine blank for a sec. I'm going to use it for something different. Okay, so what that tells me is this distance equals 1 over or root 2 on 2, right? This distance, this side of the triangle also has to equal root 2 on 2. Agreed? So the coordinates of this point, right? This is point P. The coordinates of this point, well, my x value is root 2 on 2. My y value is root 2 on 2. Okay? Would you agree with that? Now, the interesting thing is, remember way back when we first started this unit, on page 11, that we said when we're talking about the unit circle with the radius of 1, if these are the coordinates of my point, if you think about it, what's cos of 45 degrees? Cos of 45 degrees would equal the adjacent side over the hypotenuse, which is just 1, right? So wouldn't cos of 45 equal to root 2 on 2? And sine of 45 will equal the same thing, right? This divided by 1 just stays this. So not only is this my x and my y, my point value, I could think of this as x and y, but also cos of 45 degrees equals root 2 on 2, sine of 45 degrees equals root 2 on 2, because on the circle, cos and x are the same thing, sine and y are the same thing. So on a circle with radius 1, cos of any angle equals the x-coordinate of any point on the unit circle, right? And sine of any angle equals the y-coordinate of the point that lies on the angle too, right? So any point on this unit circle is also going to lie on the terminal arm of an angle, and that angle that's created, the cos and sine of the angle will equal the x and the y value of the point. Just because that's what the definition of cos is, right? Cos is the adjacent over the hypotenuse. Sine is the opposite over the hypotenuse. If the hypotenuse is 1, cos and sine become synonymous with x and y on the unit circle, right, on a radius of 1. Okay, so that's how we know the trig ratios of 45 degrees. The trig ratios now you know are root 2 on 2, root 2 on 2. What would tan be? Tan is equal to, in this kind of case, I guess, well, you could think of as y over x or sine over cos, root 2 on 2 divided by root 2 on 2. I heard, yeah, tan of 45 equals 1. Now, I'm using the degrees, but I could easily have said tan of pi on 4 as well, right? So these are your 4, this is the big deal. This is what we spent all our time coming up with. Now, because of related angles, these values are the same here, here, and here, right?
It's just the negatives.
Yeah, so here, so we would say that cos of, I write too big for these little boxes. Cos of 135 also equals root 2 on 2, but because we're in quadrant 2, it's negative. Sine of 135 is positive, and tan of 135 is negative 1. All the way down here, maybe I'll use radian measure now. Instead of saying 225, I'm going to say cos of 5 pi on 4 equals negative root 2 on 2. Sine of 5 pi on 4 is also equal to negative root 2 on 2. And tan is positive in quadrant 3. So it's positive 1. And I'm not bothering with the reciprocal functions because all you have to do is reciprocate the value, right, to find your... And then quadrant 4, I have cos of 7 pi on 4 equals positive root 2 on 2. Sine is negative root 2 on 2. And tan is also negative, and it's negative 1. So you only ever have to do any work that you have to do to find your trig ratios is really in the first quadrant. Because they're all part of that related group. So you're going to have these memorized shortly, because what you're going to be asked for, I think I mentioned this when we first started, but now I could ask you to solve, I think, you know what, lots of students find working with special angles easier than the non-special ones. Because you're restricted just to three families, right? The ones you were doing for homework a second ago, they require lots more work, I think, with your calculator, a lot more knowledge, I think. But now I could ask you to do this. Solve for theta, and I can say from 0 to 360, and you might now have a question like sine theta equals root 2 on 2. So you'd say, oh, I know that ratio. Okay, first of all, sine's positive. It's positive here and here. What angle is associated with the root 2 and 2? Oh yeah, that's my family of 45s. that's my reference angle. So I say, okay, well in quadrant 1, that will be my answer. And then in quadrant 2, it's going to be 45 away from 180, so that'll be 135. You've solved your trig equation. All in your head, right? That's where we're headed. Okay, I'm going to set one more up, and then we'll stop for today. And I might get you to fill out. Actually, I'm going to assign. I'm going to leave the 30, 60, 90s for tomorrow because that's not a good thing to do at the end of a long day. So let's flip to this one. Page 18. I think you guys could do this quite easily. They're called the quadrantal angles. Those are the angles on separating the quadrants, right? Now, if I just told you this is still a circle with radius of 1, let's just state what these angle measures are. I think I'm going to state them here. So this is 0 degrees, right? Or 0 radians as well, right? And then also it would be 360 degrees. I'll just put that down here, 360 degrees and 2 pi radians. Right. How many degrees is this? 90. How about in radians? Pi divided by 2, right? I normally don't write the rads, but this time I'm going to write it just to keep it all fresh. And what about this? How many degrees is this? Halfway around the circle. 180 degrees or pi radians. And what about this for degree measure? Do you remember what this is? 270. 3 pi on 2 radians, right? Okay. Now, if I can just figure out what my x, y coordinates are, that will be cos and sine, right? So what would the coordinates of this point be? If this is the unit circle, this whole distance is a distance of 1. This is my x and y axis, right? So what would the coordinates of this point be? 1, 0, right? Wouldn't that be the point 1, 0? So that means cos of 0, I guess I'll stick with degrees. 0 degrees is 1. Sine of 0 degrees is 0. It's kind of weird, eh? 0 degrees has 0 value. Now, what is tan of 0 degrees? Y over x, or sine over cos, so 0. Right? 0 divided by anything is 0. Now, I'm just putting 0 in because I have to put some angle measure in. Maybe I'll do pi on 2's up here. Okay, I want you to tell me what cos of pi on 2 is, sine pi on 2, and tan of pi on 2. Sorry, John, what's cos of pi on 2? Because what would the coordinates of this point be? The coordinates of this point would be 0, 1, right? So cos is 0, sine is 1, and what's tan? Yeah, we usually say undefined. Why is it undefined?
Because it's 1 over 0.
Yeah, can't divide by 0. So no value, undefined. And then this point, the coordinates of this point, I like listing the coordinates of the point like in xy coordinate form, because then you can just say, oh, cos is the first value, sine's the second. So this coordinate point would be, well, it would be -1 on the x-axis, 0 on the y. So that tells me cos of 180 equals -1, sine of 180 equals 0, tan of 180 equals 0. And then the last one, way down 270, 3 pi on 2, we've got I guess I'm back to radians. I'll use radians for this one. Cos of 3 pi on 2, sine of 3 pi on 2, tan of 3 pi on 2. Okay, so the coordinates of this point will be 0, -1, right? So I have cos is 0, sine is -1, tan is undefined. Those are easy, right? You would have got these without me, because all you have to do is figure out what the coordinate are. And then x coordinate is cos, y coordinate is y. All right, I'm going to stop talking for today, but I'm going to assign you. It's not really homework so much as just sort of organizing your thoughts a little bit. And I'm going to, if you could, see if you can read the pages talking about special angles, and we're going to finish off the 2 other families, the 30s and the 60s tomorrow. So there's a couple lead up pages. But if you could do number 1 and 2 for me of page 5.3. So it says fill in the following chart using exact values without using a calculator. So it's exactly what we just did. These are the quadrantals, right? The 0, 90, 180, 270 back to 360, sine, cos, and tan. So you're just transferring the info from here to here. It's just another way to have the info. I think some students like the chart form because you can see patterns. Some students like a visual like this, but it's just a nice little exercise to help you with your kind of your memory work too. The only thing is they ask you for the cosecant, the secant, and the cotan as well, right? And I didn't give those to you, so you're going to have to take all the ratios I gave you and reciprocate them. Be careful, there might be some undefined values in here, right? Okay, and then for number 2, same thing. Just transfer over the values from our 45-degree family, transfer them into the chart, and then come up with the other ratios, just so you have them on your paper too, right? Again, 2 ways to think of these, sort of in chart form or in creation form, right? We actually created, our family of 45s or pi on 4s. Okay, so that's it. That's it for today. So number 1 and 2 of 5.3. You can go home now, unless you have a slot 6 class. I don't know, do you have a slot 6 class?